Okay, welcome to the first section of notes. This is 2.1. This is where we start. So this is addition, subtraction, multiplication, and division properties of equality. Quite a bit of what is in here should be pretty familiar, but if it's not, let's practice, okay? So as you work through these notes, my suggestion to you is to go into the files section of Canvas under chapter 2 and take out the section that says 2.1, section 2.1 notes. What you'll do is you can either just have them up on your screen as work in your notebook as you go. You can work on your notebook beside me as you work and just watch as you go. And then you can also review the finished PDF copy of the notes that I'm going to put in the file also. Just know that it's all there for you to use as a resource alongside this video. The more you're moving your pencil on your paper, the better, okay? It is also okay to go back and rewatch things. Please do that. That's the joy of having video here. All right, so definitions, concepts. So the first thing is that there's two different kinds of things that we talk about in algebra. We talk about equations and we talk about expressions. An equation that is a statement that indicates two expressions are equal. So if I have something like a plus 3, that's an expression. When I have an expression like a plus 3 equal to something else, anytime I add an equal sign into the mix, I get an equation or an equality sign in every version. So it might be less than or equal to, a greater than, whatever. The solution to an equation is the value of the variable that makes the equation true. That's it. We're looking for what a would have to be for a plus 3 to be 7. So to begin with in this section, we want to decide if the value, the given number, so in this case it's -1/2, is actually true. And the way we do that is to put it in for x. So I have 4 times -1/2 plus 7 equals 5. We're just going to replace. 4 times -1/2, well, you can do that in your calculator if you want. I know it's -2 plus 7 equals 5. Does -2 plus 7 equal 5? Well, yes. So when something is true, we're going to write yes or true. You need to tell me that you know that this worked, okay? So let's try the second one. In this case, the value is 3. And this is the equation, so I'm going to put it in for W. -4 equals 6 times 3 minus 14. -4 equals 18 minus 14. -4 equals 4. Are -4 and 4 equivalent? No. So in this case, the answer is no. 3 is not an answer, solution to this equation. Take a look at these, try them on your own. Pick up your pencil, move it on the paper. See if you can figure out what to do. Pause the video, do the work. Okay, so I'm assuming you paused. What we're gonna do is replace the 3 in for x. 4 times 3 minus 1 equals 7. Well, 4 times 3 is 12, minus 1 is 11. 11 and 7 are definitely not equal, so that guy gets a no. And then let's see, we're going to put -2 in for y. So 9 equals -2 times -2 plus 5. 9 equals 4 plus 5. Yep, that's 9. So that's a yes. Notice also that I actually write out all the work because I think that's a part of keeping your brain organized here in algebra. The more you write down, the less you try to keep in your head, the better this is all going to go, I promise. And I've been teaching this a long time. All right. So the definition of a linear equation in one variable, that's where we're starting. Let a, b, and c be real numbers such that an equation in one variable, a linear equation in one variable is an equation that we write in the form ax plus b equals c. We also call this standard form. So when I say to you, well, the equation should be in standard form, this is what we're talking about. These equations are also often called first degree equations because that x has an exponent of 1. There's one of them. We just can't see that one. We don't write it because we humans are lazy and we don't write numbers that are already implied to be true. There are 4 properties in here that we're going to use to help us solve equations. They are the addition property of equality, the subtraction property of equality, and then there's multiplication and division down the line. What they each basically say, if we look at addition, for example, is that when I do one thing to one side of the equation, if I do the same thing to the other, the equation is still equal. So if I have A equals B and I add C to both sides, if you think of it on a balance scale, I add the same amount to both sides of the scale is still balanced. I can do the same thing with subtraction. If I take away the same from both sides, the scale is still balanced. So let's try that in reality. The goal of an equation is always, always, always to get your variable alone on one side equal to some sort of value, right? This is only the truth when we're solving equations, when there's an equal sign of some sort. Our goal is to use the rules we have to get the variable alone and change the equation, reorganize it in a way that suits us. So when we're solving p minus 4 equals 11, essentially what I'm going to do is use the property of addition to move the 4, the negative 4, from one side of the equation to the other. I can add the same value to both sides. When I add 4 on the left, it actually creates a 0. So all I have left is p, that's good. When I add it to the other side, I get 15. So I know p equals 15. Now here's the joy of algebra. The joy of algebra is that if you're ever unsure if your answer is correct, you can always check it. So you can go back in and say 15 minus 4 equals 11. Well, yeah, that works. And you can check to see if you're right. And you should, right? You know, if you're ever unsure, you can check. So you just replace the answer you got. You replace the variable with the answer you got. For w plus 5, we're always going to use the opposite operation. So I see what's connected to the w. The opposite of plus 5 is minus 5. I'm going to subtract the 5 from either side. Plus 5 minus 5 makes 0. That just leaves w on the left. Negative 2 and negative 5 is negative 7. And then I can check. So is negative 7 plus 5 equal to negative 2? Well, yeah. So I know, oops, this worked. Okay, and you're going to see me from time to time forget negative signs and other things. Just check me as we go. And if you have questions, ask. Okay, so this is just an uglier version of what we were just doing. Nothing has changed. There happens to be a fraction. Nobody will die. Everything's okay. I have a variable on the right. I have 9/4 equals q minus 3/4. If I had 9 equals q minus 3, you would just add 3 to both sides. Nothing is different here. Instead, I'm just going to add 3/4. So I get 3/4 and 9/4 is 12/4, because we just add the numerators, equals q. And I can simplify that. 12 divided by 4 is 3, so q equals 3. You didn't die. It was a fraction. You didn't get injured by it. The same thing is going to be true if I work with decimals. Now this one is kind of funky because it's an addition, but it's a negative. And the way I do deal with a negative is to do its opposite. So I'm going to add 1.2 to both sides. Get the variable alone. So I get z equals 5.8. That's all there is. You try these two. This one is tricky because look at the fractions. Remember that when we have two fractions whose denominator are not the same and we're going to add or subtract them, we need a common denominator. So for me, I'm going to use 12s. So 4 times 3 equals 12, 1 times 3. 1/4 is the same as 3/12. 3 times 4 is 12, 4 times 2 is 8. That's the same as 8/12. So really what I'm solving here is 3/12 equals A minus 8/12. And I'm using the inverse operation. So this 8/12 is being subtracted from A, so I'm going to add it to the other side. So I'm going to show that over here. So I get 8, 9, 10, 11 twelfths equals A. On the bottom, once again, I'm using inverse operations. That negative out front, I'm going to add the opposite of. So I'm going to add 8.1 to either side. And I get W equals, let's see, 19.6. All right, so that's addition and subtraction. Listen, if you're starting to sweat a little bit, reach out or watch these again. There are other resources we will use for practice too. All right, the last two rules are the multiplication property of equality and the division property of equality. They are the same rules. What they say is if I multiply an equation by the same thing on both sides, or if I divide an equation by the same thing on both sides, it's still true. So we're going to use that to our advantage. Remember that we use the inverse operation. So if something's being multiplied, we adjust it with division. If something's being divided, we adjust it with multiplication. And I say this doing all sorts of hand gestures like you can see me because I don't have the video on. At any rate, so first identify what it is. This is a multiplication problem. 12 times x equals 60. The way I solve a multiplication is with the opposite operation. I'm going to divide both sides by 12. X is going to turn out to be 5. And then remember, if you want to go check, you can. 12 times 5 does equal 60. Okay? Same thing here. Divide both sides by -8. 48 divided by -8 is -6. -8 times -6 is positive 48. The next one is weird looking. Here's the thing. Whenever it's possible, we want the value of the variable that we're using to be positive. So the way I can think about this is I can think about this as a -1x equals 8. So I can separate that negative, and I can divide both sides by -1, and I can get x equals -8. You're always going to, the most simplified version of an equation is with the x, the variable being positive. So then we look at the next one, same thing. I could also, we're going to divide by -1. I'm going to get y equals 11. Essentially what happens when you divide or multiply by -1 is you switch the signs on both sides, right? Where they were once both negative, now they're both positive. And then this bottom one, it's being multiplied, so I'm going to divide. 6.82 divided by 2.2. This is where you think your calculator would be handy, right? I don't know. What does it turn out to be? 3.1. I had to calculate myself. All right, here's two equations we're going to solve using the multiplication property. Basically what we have here is something being divided by a number equals something else. So when we want to divide, the opposite of division is multiplication. So we multiply by the reciprocal. This is like saying 1/6 times d equals -4, the other way to think about it. So what I'm really going to do, let me get rid of the extra stuff, is multiply both sides by 6/1. What happens is we can cross cancel for fractions. The 6's go away, it just leaves me with d. And remember, my goal was to get that variable alone. D equals -4 times 6 is -24. And then if you want to check. So if I put -24 in where I see d, -24 divided by 6, does that equal -4? Well, yeah. So that checks. Same thing on the other side. I'm going to multiply both sides by the denominator over 1, by the reciprocal. That's going to cancel these 5s. It's going to give me x equals -40. And again, you can check. Okay. The last few things here is to write an equation to represent the sentence. These can be tricky because you need to just read carefully. So for the first one, it says the quotient of a number and 4 is 6. Quotient is just math for divide. So the division of a number and 4, whatever number they say first is the first number, is 6. Is code for equals. So I have a number, I'm going to call it n, I don't know what it is. The quotient of a number and 4 is 6. I could also write it like this. Either of those would work. The product of a number and 4 is 6. Product is code for multiply. It says a number, I'm just going to use n, so I'm going to write 4 times n is 6. I mean, the way it reads, it would say n times 4. That's fine. It's just good math manners to write variable and number this way, right? Number times variable. It's like addressing someone you know by Mr. or Mrs., right? The next one says negative 12 is equal to the sum of negative 5 and a number. So I'm going to just do what I see. Negative 12 is equal to the sum of negative 5 and a number. So negative 5 and a number, okay? The value 1.4 subtracted from a number is 5.7. The time you're going to have to really pay attention is subtraction, right? If I say to you, I have $100, you subtracted $37 from my $100. I wouldn't do 37 minus 100, right? I'd do 100 minus 37. So typically we write subtractions in the opposite direction we read them. So the value of 1.4 is subtracted from a number. So n minus 1.4 is 5.7. Too many points. All right, here's the next screen. You try them yourself. See what happens. Take a bait and do the work. Okay, I'm assuming you paused and you did. The quotient of a number in negative 2 is 8, so I could do n divided by negative 2 equals 8. I could also write it as n divided by negative 2 equals 8. The product of a number and negative 3 is negative 24. So negative 3n equals negative 24. The sum of a number and 6 is negative 20. So n plus 6 equals negative 20. And then 13 is equal to 5 subtracted from a number. So 5 subtracted from a number. All right, this is the end of your first section. Hallelujah. Take a few beats, make sure you understand what's here, and look at the next section, or go start your ALEKS work. Either way is fine, however you want to approach it. If you have questions, reach out.